Okay, can you hear me? Okay, so let's start, okay? Good morning, everybody. Welcome here in the 5G garage of the i14y lab. My name is Alfons Mittermaier. I'm the managing director of High Street Technologies, an SME based here in Berlin. Our office is just 10 minutes walk away from here. And we are one of the partners of the i14y lab of this project. But High Street Technologies is also a founding member of the Innovation Cluster 5G Berlin. And for that reason, I was asked to introduce you here to this 5G Berlin and how it is connected or being connected to the i14y lab and other initiatives. By the way, since we are only a very few people, if you have any questions, please interrupt me immediately. Do not hesitate. Just a moment. Okay, so what is this Innovation Cluster 5G Berlin? It is a non-profit association according to German law, just like the Oran Alliance, by the way. It was founded in 2018 and it operates a 5G test network on the campus of the Technical University of Berlin and Fraunhofer Heinrich Hertz Institute. Since we are in the lucky situation here in Germany that there is real private spectrum in the range from 3.7 to 3.8 gigahertz, we applied for that spectrum on the campus of the TU Berlin and got operational 1.5 years ago. So this network is up and running, but it's continuously improved, added more technology, now also Open RAN technology and so on. So it's still work in progress. It is sponsored by the German Ministry of Education and Research. So they finance the initiative such a network could be built. And now we have also other sponsors like the German Ministry of Economy and Climate Protection, where it is about private 5G networks and such applications. Okay, and so we have a focus on two categories. On the one hand, public 5G networks as they're operated by the likes of Deutsche Telekom or Vodafone, but on the other hand, since a few months ago, we also focus on private 5G campus networks and, of course, the interaction between these private networks and the public networks. Okay, so what does it look like at the moment? So people who are familiar with Berlin, it's in the western part of Berlin, here on the campus of the Technical University. We started in one angle. Also, our coverage area of the spectrum is much larger. And we have built here on, don't know whether this works, here on the rooftop, that's what we started with. It's a classical Nokia G Note B. And now we are adding small cells, partially also in Open RAN technology, such that the radio unit, distributed unit, and central unit are split up. And we also try to try out new rollout technology or deployment technologies together with the municipality of Berlin. So new kinds of housing or street side cabinets. So it looks like a litter bin, but actually there's a street side cabinet behind it, which allows us to deploy RAN technology. Okay, let's go to the next one. Okay, and as already said, this 5G Berlin test network is at least partially funded or sponsored by different ministries, German ministry, but also by the European Union. We have a focus on research on the one hand. That's why we have, for example, 4 Fraunhofer institutes as partners, but also universities, of course, the Technical University of Berlin, but also the Technical University of Chemnitz. But from the very beginning, it was one of the goals of this 5G Berlin test network to also transfer research results into commercial products and services. And this is why there are many companies, primarily small and medium enterprises, part of that initiative. And that's what you can see here. So we have here the members of the 5G Berlin Association, and then there are companies that are either also members of the 5G Berlin Association or collaborate in some of the research projects. And in order to facilitate the transfer of research results to commercial products and research institutes, we founded the Open SDN and NFV lab, which is another lab connected by fiber to the 5G Berlin test network, about 15 minutes away from here. And here we have a series of companies who collaborate in order to commercialize the research results. For example, last year we had a collaboration of 2 of the small and medium enterprises, and they provided Telefonica Germany with the SDN controller for their microwave network. And at the moment we have about 40,000 devices connected to that SDN controller, and this is, let us say, a result of transferring research results and research collaborations into products and services. Okay, here a bit of geographic information. So we have here in the campus of the Technical University of Berlin. In this angle we are already operational, but we want to add macro sites and many more small cells to the network. We have this OpenSDN and NFV lab about 2 kilometers from here. And now it's about connecting the i14y lab, such that we have on the one hand an outdoor network, which is really transmitting and where we can do experiments, outdoor experiments. Then we have here the i14y lab, where it is about testing Open RAN technology with big partners like Deutsche Telekom, Vodafone, Telefonica. And then we have the OpenSDN and NFV lab, where primarily small and medium enterprises can bring in their software, and by the connections to the lab, the software can be connected to a live network. Okay, let's say from the technology that is there, we have here this 5G Berlin test network. And as already said, we started with a macro cell of Nokia, but we also have PON technology for backhauling, for Wi-Fi backhauling, or small cell backhauling, so XGS PON, WDM PON. We have now also small cell technology from Airspan, but ever more technology is added to it in order to see how it is in a live network, in contrast to what we have here, where we have a lab. And we are about, at the moment we have just dark fiber, but we are about adding a DWDM system of ADFA. And then we have here about introducing more products, like another DOC implementation of a startup from Berlin called AirPulse. We have the CEO here present, then a 5G core network, and we as highstreet Technologies, we provide the ONEP system for service management and orchestration, such that we have here a complete network, and by connecting it to the i14y lab, we can always very quickly integrate new products that come here for testing into the overall solution. Okay. As already said, and as the representative of Capgemini said, OSS, network management or service management and orchestration, as it's called in the ORAN Alliance, is quite important. We decided to go with ONEP, an open source platform. And as you can see here, as we have to integrate many, many different technologies, so it's not only about RAN and the mobile core, but you have all these transport technologies as well. We have many interfaces which we are standardizing in the ORAN Alliance. So with regard to transport, that's the ORAN Alliance Workgroup 9. That is being integrated by Open Daylight and open source SDN controller. This is exactly the one that Telefonica deployed last year in its microwave network in Germany. And then, of course, it requires the typical FCAPS functionally, fault management, configuration, and so on. Also a data lake as the basis for machine learning. And then we have many applications. And there's a lot of discussions about the radio intelligent controller, near real-time rig, non-real-time rig. But here within the ONEP system, we are extending that beyond the radio access network, because you can also have applications or microservices coming as a Docker container for optical networks or packet networks or microwave networks. Yeah. And these applications can be integrated in exactly the same way as you would integrate an R app. Okay, this is something we are working on here. And yeah, as you can see, this ONEP system is being connected to this network for service management and orchestration, such that you get one platform for the whole network with a flat architecture, and yet you get rid of all this many, many controllers, one stacked upon the other, which causes a lot of difficulties when integrating it into an end-to-end management solution. Yeah, and yes, of course, because of this myriad of APIs, standardization is important. That's why we are working on a uniform network model within the ORAN Alliance. The status is such that we proposed this uniform network model as a concept last year. It has been approved by the ORAN Alliance Workgroup 9, is now under review by the Technical Steering Committee, but we are quite optimistic that it will be approved maybe in June or July, something like that, and that we will have a standard here, presumably based on TAPI topology by the end of the year. We have already started implementing it, and we will get it running here towards the end of this year, beginning next year. So in this way, we will have here a solution based on ONEP for service management and orchestration, including all the technologies. Okay, and sorry. Okay. Yeah, and Werner von Siemens. And yeah. Mm.
Is there some effort made to get connected to these other initiatives?
Well, let's say this where we started with, you can see, just a moment, I go back here. Where is it? Okay, so here on this campus, we have basically already two initiatives. There is this 5G Berlin test network, and there is the Campus OS, which has a focus on private 5G networks. And there are also fiber connections to Fraunhofer IPK. And their first talks are taking place also to the Werner von Siemens Center. And within this Campus OS project, just to give you a little bit of background, so the German government decided last year, it was sometime last year, to put a lot of money in private 5G networks, preferably on Open RAN technology, but private 5G networks is a big thing. And that's why they also gave 100 megahertz of the 5G spectrum for these private networks in contrast to many other countries. And we can already see today that we have much more momentum here in Germany in this area than in other countries where all spectrum was given to the mobile operators. So we think this is a completely new market. And we are trying to connect it. And the Campus US project is just the lead project, but there are several other projects which are application projects. For example, we are collaborating to one in Leipzig where it is about 5G networks in hospital with the hospital of Leipzig and the ICAS, which is a research center on medical technology. And beyond this program, there is also a French-German program on these private networks, and we as a company, we're collaborating, or we will build a 5G network south on a business park southeast of Lyon in France, and we will actually use the same ONEP system, or widely the same ONEP system that is deployed here. So this, it's ongoing, but it's still in its infancy. Okay. Yes. Mm. Mm. And I think it's in 2 weeks when we first meet all these satellite projects and the campuses projects. Mm. Mm. So a lot of things are ongoing in that area, but yeah, here it's about the i14y lab, so I focused on that. Okay. Okay, yeah, so that's going on here, integrating the network with ONEP. So with campus networks, we will have to simplify the ONEP system as it was designed by big companies for big networks. It was initiated by AT&T and China Mobile, two of the biggest operators on the globe. And for campus networks, we will downsize it to make it more handy. And we will see whether, so let us say an enterprise edition of ONEP, and we will see who will make the race at the end. And yeah, but nevertheless, here in i14y lab, as we have 3 mobile operators as partners, it's about the big networks. And as we cannot afford, neither here in this lab, nor in the 5G Berlin test network, nor in the OSNL, to purchase tens of thousands of devices in order to do this testing, we have part of the network as real network elements. So this RAN equipment that we have already up and running, or microwave equipment that we have in our lab, optical equipment provided by ATVA, an equipment vendor where we can connect to a real network, such that we have a real 5G network, also it's small. And in order to see how that scales, yeah, we are working with device simulators. And so we created some, simulated network. And we used the site locations in Germany provided by the German regulator. These are more than 90,000 sites. You can see it here. These are the blue dots. So here it's quite a lot. And we made an assumption. It's driven a bit by Telefonica, so saying that 25% of the network are actually connected by fiber, 75% are connected by microwave. So we picked 25% of the sites and said randomly, these are the fiber sites, and connected all the remaining 75% by microwave. These are here the green links, and the blue ones that you can see here are the fiber connections. So for the northeast of Germany, we decided to have the core sites here in the center of Berlin. And so we have, and all these are connected by DWDM systems, simulated DWDM systems, and this allows us how to test the ONEP system, which is used for service management and orchestration, against something that represents a real network, so a Germany-wide network. Okay, and this is something that is still ongoing. And now I would, and in the afternoon, from I think 12 o'clock onwards, there will be a live demo with connection to this 5G Berlin network via VPN connection, where Alex, a colleague of mine, will demo a network slicing use case or repeat a network slicing use case. So in which is shown here. This is just to give you what you will see later on. That's something that we did together with Berlin Fire Brigade, Charité, a quite big hospital here in Berlin, and a series of others, where we tried out network slicing in a real network. So we created 2 network slices, let's say the general purpose or best effort network slice, and then an emergency network slice for the fire brigade for scenarios when there is, let's say, an emergency case and the fire brigades use these handheld cameras in order to transfer videos to the commander. And of course, it is important when there are spectators around and streaming the scene that they do not consume all the bandwidth, and that the fire brigade actually keeps at least a chunk of the bandwidth. So we created 2 network slices, and then by an app used by the Berlin Fire Brigade, one can activate the emergency slice, and we could demonstrate that it really works in a live network. And this will be shown by Alex later on. And this is why this is just an appetizer. Okay, and yeah, that's how it works. And in order to give you also an idea of what this ONEP system looks at the moment, I would like to stop the presentation now and log in. Okay, just a moment. So here, because of the VPN connection, everything is a little bit slower. So in reality, the system reacts a bit faster. So you can see here that at the moment we have a bit more than 20,000 devices connected, most of it just simulators. And yes, we are still connecting, and here you can see an alarm status with these simulators. We can also generate alarms, create alarm storms or certain alarm patterns. We can also create performance data and such that we have something like a digital twin, but this is something we're still working on, I have to admit. So it's not fully functional, but at the end we can create alarms and check the robustness of the ONEP-based service management and orchestration. Then there is a network map. It also takes a little because of the many sites. So what you saw on the slides before with the a bit more than 90,000, just a moment, I zoom out. I said it's a little bit slowlier than normally. Okay. By the way, the backbone network is the so-called Germany 17 network, where we have simulated fiber connections. And here you can see we have these sites. Yeah. Okay. Here you have, for example, an optical service which we routed using an application provided by ADVA, so an optical equipment vendor. from Hamburg to Munich. So as they know their equipment best, they developed algorithms for doing so, and this comes as a microservice in a Docker container. In the radio access network, people would call it an RApp, but in optical network, maybe we should call it an OApp, don't know. But from a technology-wise, it's exactly the same thing. Yeah, and when you zoom in, yeah, you can connect to microwave links and so on, yeah. And this is polarization plane. There's also another R app which is doing the microwave calculation, such that before you can put into operation a microwave link, you need a license for it. And so you have to do all these calculations, ask the Bundesnetzagentur, the national regulator in Germany, to get the license, and for filling in the data, you have to do this microwave calculation. And also that is just coming as a microservice or an R app. You deploy it as a Docker container and on app, and you do not longer need dedicated systems. You have open APIs, you can automate it. We even tried it out that one can calculate tens of thousands of microwave links in Germany in the range of minutes, yeah. Where usually people doing it manually will take months to do that. Okay, and then of course you have things like fault management. So here you can see alarms coming from simulated open ROADM devices, but in the same way you can have it. Just a moment, we have to hear a lot of open ROADM devices. We have configuration management such that you can change the parameters to the Yang models. So here you can see there are different devices, distributed antenna systems of CommScope. This is a macro base station of Nokia, Open RAN equipment, microwave systems of Ceragon, so it's all the same. And yeah, I think I've already consumed 30 minutes. And so we can show you more in the afternoon of that. You can ask questions, but here the primary message is that we are building here a lab. We have a 5G outdoor network, which is a small but close to real network, where we try out new technologies in RAN, in transport, and even in street-side cabinets and so on, such that we have something that is realistic for both public 5G networks as well as private 5G networks, and the combination of both. We have OnApp as the management platform, but instead of having one controller, domain controller, hierarchical controller, and what all the people call it, we abandoned that, and we have just a flat architecture where everything comes as a microservice in a Docker container, easily deployed. And we think that this is a must for private 5G network, and simply for the sake of complexity. And we will see whether such a simplified approach would also make it into public networks. Okay, so that's all from my side. Thank you. If you have questions, please do not hesitate to ask. I don't know whether we have a few more minutes. Do you know? Well, the next one is already waiting. But anyway, in the afternoon here in this glass box, Alex and me, we are there to answer your questions and show you more things. Okay, so thanks a lot.